Greetings and welcome to the video on simple frequency distributions. Let me get the title up on the board here. Simple frequency distributions. Okay, when the data set gets too large really to list all the values separately as we would do in a rank order distribution. And if you haven't seen the video on rank order distribution, I would advise you to go and watch that separate video at this point. But when the data set gets too large, it's really inconvenient at that point to try to list all the separate values. And so what we do is we kind of switch into this simple frequency distribution way of ordering the data set, where really we're still using this random variable x. It's the variable that's being studied, and in this particular case x is still the number of pull-ups that are going to be measured as part of a PE skills test, for example. And we're going to use this designation f for frequency, and I'm just going to put over here frequency, thus getting to the simple frequency piece of this distribution. And frequency really here, I'm just going to put in parentheses, is really just the number of cases at a given value of x. Okay, you'll see here in just a minute what that actually means, and intuitively you might already have a sense of what that means. All right, so if we just continue on with this PE skills test example, knowing that we're measuring again the number of pull-ups and of students in a PE course, instead of 10 scores as we did with the rank order distribution, let's just say now we had multiple classes or sections of a PE class, and you measured pull-ups across all of these students and combined them into one large data set. Instead of just 10 students, now you've got, say, 112 students. Well, how would you deal with that information? Well, we still want to go and rank here from high to low, and we're going to do that. But let's just say that we still had that variable x. But to this, what we're going to add is also that f component, the frequency component. And here's kind of how this works. So let's just say that on this random variable x, we had somebody that they were able to complete 20 pull-ups. And let's just say we didn't have one individual that can do that. We had a frequency of 2 individuals that could do that. Okay? And let's just say at 19 pull-ups, we had nobody that could complete 19 pull-ups across these 112 students. Let me just put up here, or I'll just put right over here, that now we have, say, 112. Okay? Well, let's just keep going on with the example. So how many were able to complete 18 pull-ups? Let's just say in our example, 3 were able to complete 18 pull-ups. And this is just going to get old here really quick because you probably already have the intuition for this, but at 17, let's just say there were 6 that could complete the pull-ups. At 16, it was 8. At 15, let's just throw out the number 1. At 14, let's throw out some big numbers now. Let's say there were 21 that could do 14 pull-ups. And at 13, there were 35 students that were able to, out of our 112, that were able to complete that many pull-ups. At 12, there were maybe 8 students, and maybe another 8 students. Well, let's just say at 11, there were 0 again. Let's say at 10, there were another 8 students. Should be getting close here, adding this up. As I go, this would be 4. Let's just say at 8. There was 7. At 7 pull-ups, we had 5 that could do that number. And let's just complete this out with saying 6 and 4. So this number right here would add to, if you added this entire frequency column up here, you would get to 112. So again, our N here was we measured 112 students doing pull-ups. That's what this random variable X is. We had 2 students that could do 20, 0 that could do 19, 3 that could do 18, 6 that could do 17, so on and so forth, all the way down this list. And we can still nicely get things like our N size, which we already have, and you would calculate it down here. Okay, this is where you would show your N size. We could still get things like, well, what is our high value? Well, because we've rank ordered it but just included the frequency component here, we can still get the high value. So our highest value, I'm going to use this magenta color here, is this 20. Okay, so my high score or high number of pull-ups was 20. My low down here, 6. Low, 6. Range again is going to be high score minus low score. So in this particular case, this is going to be 14. And again, you can get a sense of the spread of the data, and you can kind of get a sense of where the middle might be when you kind of look at the frequency. And the nice thing about this particular way of organizing the data is that if N is greater than 20, i.e. you have more than 20 cases that you're measuring, or 20 individuals that you're measuring pull-ups for, and the range is less than or equal to 20, then generally speaking, this will fit on a single page of 8.5 by 11 kind of paper, and this tends to be a good way of kind of organizing your data. If it's larger than this, then we really need another organization distribution kind of tool, and that will lead us into another video. Thanks for watching the video on simple frequency distributions.